Hey everyone, welcome back to your learning journey. Now, in this very special video, we are going to understand how to perform the model selection for a machine learning task. Now, if I want to speak about this model selection at a very high level, this model selection, it's actually a task where I'm going to select a given statistical model from the set of candidate model for a given data set. So that's exactly what a model selection is. So it's all about selecting which model performs best for a given task. And that's what a model selection is all about. And when we talk about this model selection, we've got various steps. So in order to select the best model for a machine learning, the first step is obviously gather the data. We'll have to get the data from various data sources. I can have the data present in my local database. I can have the data present in my S3 bucket that is in my cloud system, or it could be in on-premise system. So first thing is I'll have to fetch all those data and keep it in a single place so that we can begin by performing the analysis. The easiest way is creating the data as a data frame so that we can perform various check on this given data set. Now, when I say various check, it comes under we'll check for any anomalies in a given data set. We'll check for missing values in the data set. And if I have any incorrect values, I'll go ahead and I'll perform the cleaning. And all these steps, we call it as pre-processing of this given data set. Along with that, as per the data that we are working with, sometimes we are required to convert the categorical data into a numerical format. Now, in doing so, we've got various methods. If I'm dealing with a rating based categorical data, in such scenarios, I can make use of label encoder. If I'm dealing with nominal data or the data which contains just a list of names, in such scenarios, we can make use of one-hot encoding. Coming to the numerical data, if I feel like all the data in my individual columns at a different scale, then it's highly recommended that we perform the scaling. Some of the common scaling methods that we do are standard scaler or a min-max scaler. Now, once we fix all this raw data and once we prepare the data set, the next thing that we do is we'll go ahead and we'll perform the statistical analysis. Now, in this step of statistical analysis, we employ various methods for analyzing my individual column. I can perform the covariance and check how one variable is affecting another variable, and to quantify it, I can make use of the value of correlation to understand the effect of one variable over another variable. Suppose if you are working with linear model, we'll have to check the issues related to multicollinearity. So we can find the VIF score and see whether we have any multicollinearity exist for a given data set. And if the statistical data, if it contains the outlier, so in such scenarios, we can ensure that we are going to scale the values, or we can ensure that we are going to specify a threshold value. And if it is greater than a threshold, we are going to limit it such that it lies within the required range. So we can do all these things under the step of statistical analysis. And along with that, we'll go ahead and create the visualization to understand the concept of correlation. I can make use of heat map, or I can make use of scatter plot and do all this analysis. Once I'm satisfied with my initial analysis, then, yes, only then we'll go ahead and build the model. Now, before we build the model, always ensure that you split the data into the two parts at least, training set and this test set. And while splitting, ensure that you get this stratified split. Stratified split is a scenario where you are going to ensure that the distribution in my population is same as the distribution that we are getting in the subset, that is the sample that you are selecting. And then you'll proceed ahead and apply this training data on your model that you have initialized and perform the training. Once the training is performed, you'll check the accuracy on the test data, and at the end, you're going to present the result. So this is the high level steps that is involved in machine learning or deep learning. Overall, it's the same. Maybe in the scenario of deep learning, you don't go deep into the feature engineering because feature engineering part will be taken care by the neural networks. But more or less, this is the high level steps that will be involved when it comes to machine learning or deep learning. Now, talking about this machine learning in general, we've got various types. Majorly, I can classify my machine learning into supervised machine learning and unsupervised machine learning. In the scenario of my supervised machine learning, it's like we are supervising the learning. Just like whenever we are teaching our child, we'll be supervising their learning, isn't it? If I'm teaching my child with the help of a flashcard, I'll tell them, hey, this is the image of apple, apple apple. This is the image of ball, ball ball. So I'm going to teach my kid in a supervised way. In the same way, when we are training the machine learning, we have a supervised learning approach. Now in this supervised learning approach, I'll make use of my training features as well as my label. Together, I'll use it in performing the training. Here, in the scenario of my supervised learning, my machine learning model's possible outputs are already known. So my data will contain the features that is in my input data as well as the correct answers or the output that we are expecting. Now, this is a scenario of supervised learning. And under this supervised learning, I can actually specify two tasks. We've got two tasks in supervised learning. One is a classification task. Two, it's a regression task. In the scenario of a classification, here we are trying to predict the categorical data. We are interested in predicting a categorical data. In the scenario of regression, we are trying to predict a real number. Okay, we've got majorly two types of tasks. One is classification task and the another one is a regression task. Depending on my outcome variable, I can classify into one of these tasks. Now, depending on our data set, if my data set contains only the features, then in such scenarios, we call the machine learning approach as an unsupervised learning. Here, the overall idea is to learn the complex representations by looking at the similarities between the given data set itself. So it will try to understand the pattern without we as a humans giving the information. It's like giving the puzzles to a small kid and we'll ask him to explore himself. Maybe you can think of them as a building blocks. You'll give the building blocks to the kid and the building blocks will be used by the kid to construct his or her own imaginary house, isn't it? In the same way, the unsupervised learning does. It's going to use the data set and finds a pattern between the data set itself. And in this scenario, we will not have the labels beforehand. Hence, we call the given data set as an unlabeled data. So it is going to observe the similarities between the groups of objects and most of the time it will ensure that it will be included in the appropriate clusters. Okay, so this is about the unsupervised learning. Now, when we have these different kinds of approaches, now the question is how can we select the model? Now, when we talk about the overall approach when it comes to selection of machine learning models, so here the overall approach is like whenever we are dealing with unbalanced data, first we will have to ensure we follow a valid resampling strategy. Now here, whenever we are doing the resampling, I can ensure that I'm performing the stratified sampling to ensure that we have the correct distribution of the data set. And sometimes I can go ahead and create the new variables as well. Now this is very important whenever we are given with the data set and it has large amount of features. In such scenarios, we will transform the data. We will get its principal components so that we can reduce the dimensionality. We can also make use of autoencoders model, ensure that we learn the latent space representation of a given data set. And because of this latent space representation of the given data set, I can now use that compressed data to train my machine learning model. And sometimes I can also make use of clustering to create new features as well. So this is one scenario where I can create new features. And in order to prevent the overfitting, outliers and the noise whenever we are dealing with linear regression, obviously it is suggested to use regularization techniques like lasso regression and the ridge regression. And also, if you're dealing with the healthcare data where you have a lot of compliance, in such scenarios, it is recommended that you consider the strategies for building the interpretable models, especially if you're working in the highly compliant relevant sectors like healthcare or a banking. It's very important that you should be able to interpret the model that you're building. So this is the overall approach that you have to keep in mind. And the another approach that you can think about is like you can make use of an approach like we've got an algorithm that is called as SMOT. Using this algorithm, you can also balance the data. So this is the high level approach that you're going to follow while working with the data set. Now, whenever I'm selecting the model, some of the elements that would actually affect the choice of my model are: one, obviously, the accuracy of the model; two, the interpretability of the model; three, complexity of the model. So if the model is too much complex, we'll try to stay away from it. Next, scalability of the model. Can I extend it to a higher data, or can I extend it with the higher amount of data that I have for my enterprise? So that is one thing that we are going to consider. And more importantly, this is the major factor, guys: how long it would take to build, train, and test the model. See, this is an important factor. And also, how long does it take to make predictions using the model? And does the model meets the goal? So we are going to ask all these questions, and depending on the answer for all these questions, we are going to choose the model which is relevant to us. Talking about the supervised learning, we've got linear regression model. Now here, this linear regression model, it's a statistical method which will help us to summarize and study the relationship between two continuous variable, or it can be more than two as well if I'm dealing with multiple linear regression. Now, in order to find the best values is nothing but finding the parameters of a straight line or a hyperplane, which will help me to fit the maximum amount of data points. And that is what a linear regression data is all about. Here, my outcome variable is continuous in nature. So if I'm someone who is interested in predicting the future value, which is continuous in nature, then it is recommended that we start with regression algorithm. Now, apart from this linear regression algorithm, we've got another model that's called as logistic regression. Now, don't get confused, guys, when we say logistic regression. It's not for regression task, but it is used primarily for binary classification. It is used primarily. So remember the term, it is used primarily for binary classification. And it's a special case of linear regression where my outcome variable is categorical in nature. Now what this is going to do is, this takes the linear combination of the features and apply a non-linear function that is sigmoid on top of this. If I want to write this mathematical expression, I'll write this logistic regression equation as 1 over 1 plus e power minus z, where my z is given by w0 plus w1 x1 plus w2 x2 up to wn xn. So you can clearly observe I'm applying this sigmoid function on top of my linear regression output. Hence, we call this as a logistic regression problem. If I'm dealing with the data where I'm sure it can be linearly separated, and the outcome that I'm looking out for, it's a categorical in nature, then I will use this logistic regression. Next, we've got k-means algorithm. Now this k-means algorithm, here what you're going to do is you're going to make use of the data set, and then you'll try to split the data set on the basis of mean distance to the cluster centroid. Here, you're going to select two random points as a starting position, and then you compare these data points to all the other points to find out which starting position is actually closest one, and this will be the first pass. And then you'll have your initial groups, and then you'll go ahead and continue this operation. You'll find the mean of each group, and that new mean will be the newest cluster centroid, and you'll repeat this activity, and you'll continue to do this activity until you have got the stable cluster. So here k is nothing but the number of clusters that we are trying to create, and we use the means because we actually calculate the overall mean. Okay, so that is what we call it as k-means clustering. Here it takes the average of all the data points in one group, and once I find the average, I'll get that new average will be the new starting point. So this is the overall idea behind this k-means clustering algorithm. So here k-means is a clustering algorithm. Now don't get confused guys, the k-means algorithm that we have just learned, so this k-means is an unsupervised learning. Okay, it comes under clustering algorithm, but when we talk about KNN model, that is the k nearest model, nearest neighbors model, this is a classification algorithm. Okay, this can also be used for regression, but this is majorly known for classification, which comes under supervised learning. My KNN model comes under supervised learning. Now in the scenario of my k nearest neighbor model, this model is also known as lazy learner. Okay, this model is also known as lazy learner. Now let's say we have a data set of football players who needs to be grouped into k distant groups on the basis of similarity. Then in such scenarios we can make use of k-means algorithm. So if I have a new football player who needs a position, then what we can do is, in a high level, I'll take the 5 football players in our data set with the measurements who are actually closer to the new football player. Now, depending on that nearness, we are going to get the odds on the position that we should assign to a new player. So in this way, my k nearest neighbors classifier will help me to classify the new player to which team that I want to assign to. For example, if I say k is equal to n, then I look out for n nearest neighbor, then those nearest neighbor, whichever is the one that I'm getting the most number of votes, that is the class that I'll be assigning. So this is about my k nearest neighbor model. So what I'll do, I'll take the measurement from the given data set to the newest data point, and on the basis of votes, I'm going to decide to which class my new data set would belong to. So we use this k nearest neighbor model when we are dealing with the task of supervised learning. Now apart from this, we've got another model that's called as support vector machine. Now this support vector machine, it's also a supervised learning algorithm. Here we make use of a hyperplane to separate the classes. Now this hyperplane can be a linear hyperplane, or it could be a polynomial hyperplane, or it can be a scenario where I perform the transformation on a data set and we call that hyperplane as a Gaussian hyperplane. So we've got 3 types of commonly used kernel, and we use that kernel to separate my data points. Okay, so this is about my support vector machines, that is SVM model. Now here when we are working with this SVM model, we'll normally start with linear model, that is linear kernel, and if that is not sufficient, then we'll make use of Gaussian kernel. If that is also not sufficient, we'll try with polynomial kernel. And the next model that we have is decision tree and random forest. Now in the scenario of my decision tree, here what I'll be doing is I'll be constructing my data set. I'll take my data set, and once I take my data set, I'll split into multiple parts on the basis of a specific condition. Now this decision of condition will be based on the value of loss, and this loss is what we have to specify during the initialization of the model. Now once we have the decision tree, so we can go ahead and interpret the decision tree, and it is actually an easier one when it comes to interpretation. Okay, but one of the disadvantages that we would face while working with this decision tree algorithm is overfitting. So overfitting is a common scenario that we would observe while working with this decision tree model. Hence, in order to avoid the overfitting, in order to ensure that even we are not doing the underfitting as well, we've got an algorithm that's called as random forest algorithm. Now this random forest algorithm, so just like the forest is made up of multiple trees, I can say random forest algorithm is made up of multiple decision trees. So I'll combine the results from multiple dictionaries so that I'll be representing my output in an efficient manner. So here, while getting the overall output, I can perform the activity like aggregation. This aggregation can be a classifier, like I'll take the odds. In case of regression, I'll take the overall average. Now, once all the machine learning models have been exhausted, especially statistical models, if I'm still not satisfied with the output that I'm getting, then you can go ahead and choose the neural network. Now, this neural network, we call this as a neural network because this is how a neural network structure would look like. A neural network is consist of series of neurons which are connected together in the format of a network. Now, each layer, okay, we basically have three layers. We've got input layer, hidden layer, and output layer. Each layer will have one or more than one neurons. And inside each neuron, two things will take place: linear operation and activation. So you'll apply in combination, and at the end you're going to get the output. In order to optimize the parameters, you'll make use of gradient descent to optimize the parameters of your neural network. Okay, so the first thing that we always do is first we'll try to apply the machine learning models, and we'll start with simple machine learning models. So if you are able to get the highest accuracy with the simple machine learning model, we tend to stick to those simple machine learning models itself because it is easy to interpret. Now, if the data that we have is unable to fit in the simple machine learning models, then we go ahead and increase the complexity. As we start increasing the complexity, we also have to keep in mind about the model interpretability, especially if we are working with compliance related industries like banking, insurance, where people are involved. You don't want any machine learning model to go into the production and you find that it is biased towards a particular race, and that is a very bad thing happening for a brand, and no company wants to be in that position. So ensure that you select the model if you're working in any industry that where the model is interpretable. And as you progress, so you can go ahead and further increase the complexity, use the models like decision tree. If the decision tree is overfitting, use the random forest. If nothing is working, go ahead and work with neural network. Okay, so this was about how you can select the model for a given data set. Okay, I hope you guys have enjoyed this video. So thank you so much for watching. I hope you have enjoyed this. If you have enjoyed this, please confirm by typing as yes. And I look forward to seeing you with more such content. Thank you for watching. Subscribe to our channel.